Hello everyone, welcome to YouTube channel Learn with Gisela. So from this video we are going to start with new chapter, that is chapter 2 of NCERT 9th standard. We are going to learn about important concepts related to polynomials in this video. So various topics which are covered in this video are what are algebraic expressions and polynomials, what is the difference between the two, polynomials in 1, 2 or 3 number of variables, polynomial function, standard form of a polynomial, different types of polynomials based on number of terms, different types of polynomials based on degree of a polynomial, and last we are going to take constant polynomials and zero polynomials. So these topics are being covered in this video. So let's start with the first topic, that is what are algebraic expressions and polynomials. So first of all, what are algebraic expressions? An algebraic expression is an expression which is made up of variables, constants and exponents that are combined using the four mathematical operations such as addition, subtraction, multiplication and division. So we can say an algebraic expression is an expression which is made up of three things: variables, constants and exponents, and we combine them using four mathematical operations: addition, subtraction, multiplication and division. As you can see in these examples, we have made the use of variables also, constants also and exponents also. Right. So various examples of constants, variables, exponents are as follows. Constants are what? Constants are the ones which take the fixed numerical values. Like over here in the first example, we have 7. Right. That is a constant. So it has the fixed numerical value. We have 1, 2, 3, minus 5, minus 12. Over here in this example, again we have 7. So these are the constants. What are variables? The symbols, basically they are the English alphabets which we use as symbols, which can take any real value, x, y, p, q. They can have any value. All right. So these are variables. What are exponents? Exponents are the ones which are the base and the power, like x raised to power 7. That is the exponential form where x is the base and 7 is the power. So over here in the first case you can say x raised to power 2. Even in this term 6xy, over here x is raised to power 1, y is raised to power 1, y square. Right, over here in this example we have p raised to power 2 by 3. So these are exponents. Right. So basically algebraic expressions are those expressions which are made up of three things: constants, variables and exponents, and they are combined together using addition, subtraction, multiplication, division. These are the four mathematical operations. Right. So further we can say a combination of constants, variables and exponents together with fundamental operations is called algebraic expressions. Okay, so now algebraic expression is clear to us. What are terms? Terms of an algebraic expressions are parts of the expression separated by plus or minus. For example, in the expression 5xy minus x square y cube plus 4, there are three terms. They are joined by plus and minus. The two mathematical operations used over here are minus and plus. Right, so three terms are what? 5xy minus x square y cube plus 4. All these are the three terms which are used in this algebraic expressions. And each term has two parts, the number part and the variable. Over here the number is 5, variable are xy. Over here the number is 1, coefficient we can say is 1. The variable used is xy. Over here in 4 we have only the constant, and the variable is also there, but it is raised to power 0, and we know that anything raised to power 0 is 1. So 4 into 1 is 4. There is a variable but its power is 0, and therefore anything raised to power 0 is 1. That we are not mentioning over here. Right. Now next, what are like terms and unlike terms? So terms which have same variable part are called like terms, and terms whose variable parts are different are called unlike terms. And as we know that like terms can be added or subtracted because they have the same variable part, whereas unlike terms do not have the same variable part, so we cannot do any mathematical operations on them. So in this expression, if you see, what are the like terms? Let us see. So over here 6x square y and minus 5x square y. These are like terms. So together we can say it is x square y. Now minus 2xy and plus 7xy will give us plus 5xy. Now minus 2xz doesn't have any other term which is a like term with it. So as it is, it will come. And similarly 5xy square will come as it is. So over here we have used mathematical operations on the like terms, whereas unlike terms have come as it is, right? So next comes polynomials. What are polynomials? A polynomial is an algebraic expression which is made up of variables, constants and exponents that are combined using the mathematical operations such as addition, subtraction, multiplication and having non-negative integers as the exponents of the variable. Now what does it mean? It means that polynomial is also an algebraic expression which is made up of again three things: variables, constants and exponents, and they are also combined using mathematical operations such as addition, subtraction, multiplication but not division. They do not involve division. Very important point to note. And another important point over here is they use non-negative integers as the exponents of the variables. That means whatever variables we are using, x, y, z, they will have non-negative integers. That means only positive integers and 0 also. So we can also say whole numbers, right? So power of the variable will always be non-negative integers. And second thing, division is not involved over here. So these two things have to be kept in mind, right? Now next is a word polynomial is derived from the Greek word poly, means many, and nominal means terms. So together it is said that it involves many terms. Many terms does not mean infinite terms, right? So we can say a polynomial can have any number of terms but not infinite terms. Like it can have 4, 3, 2, 1 term, but it cannot have infinite terms. Otherwise it can have any number of terms, right? So now we can say a polynomial is an algebraic expression in which the variables have non-negative integral exponents, that is whole numbers only. That is, the exponents of the variable are non-negative integers, right? We cannot have minus in the power. The exponents of the variable have to be non-negative integers. It is always positive, or it can have 0 also. So that's why we say whole numbers, right? Now here are some of the examples. Let us see whether which one is a polynomial, which is not a polynomial. So in the first case, all are positive exponents, so it is a polynomial, right? As you can see, all are positive, so it's a polynomial. Second one, also positive powers are there, x raised to power 1, y raised to power 1, so it is also a polynomial. Now in third case, y, if we take it in the numerator, we have to reciprocate the base. The positive power will become negative power, and because the polynomials do not involve negative integers, therefore it is not a polynomial. Now let us take the case of fourth example over here, root x and root y. Now these are the radical forms. If you write in exponential form, you will get x raised to power half and y raised to power half, which is again a fraction. It is not an integer, right? So it is not a polynomial. Again, this is not a polynomial. So very important point to note over here, in a polynomial we should always have a non-negative integral exponents. That means the power of the variable should always be positive, right? Now let us learn the difference between algebraic expressions and polynomials. We can say all polynomials are algebraic expressions, but all algebraic expressions are not polynomials. Now to clear this statement, let us take few examples. Suppose I take x square plus 6xy plus y square plus 7. It is a polynomial in x and y. Two variables are used and the powers are positive integers 1 and 2. So this is a polynomial as well as algebraic expression also, right? But algebraic expression like 2x plus 1 by y plus 7, it is not a polynomial. Why? Because here the power of y is negative integer, y raised to power minus 1. Right? So we can say that this is an algebraic expression but not a polynomial. Whereas the first example was a polynomial, and so it is an algebraic expression also. Right? Let us take few more examples. Now over here, algebraic expression y cube plus 5 root of y minus 6. Now again, root of y has the power in a fraction form, y raised to power half in the exponential form if we have to write. So this is no doubt it's an algebraic expression, but it is not a polynomial, right? So the important point to note over here is for any algebraic expression to be a polynomial, first of all, it must not have a variable inside the radical symbol. That means in under a root sign. It must not have any negative exponent, that is minus in the power, and it must not have fractional exponent in the variable, right? So we conclude that all polynomials are algebraic expressions, but all algebraic expressions are not polynomials, because polynomials involve only non-negative integers as the power of the variable. Yes, this thing has to be kept in mind. Now let us learn about polynomial in 1, 2 and 3 variables. So first of all, a polynomial involving one or single variable is called polynomial in one variable. For example, x square plus 6x minus 12. Only one variable is used, that is x. And there are three terms involved, x square, 6x and minus 12. Similarly, we have y square minus 3y. In this also two terms are there, y square and minus 3y. Only one variable we have used, that is y. Right? Now, a polynomial involving two variables is called polynomial in two variables. For example, x square minus 9y square. So the two variables used over here are x and y, and the two terms are x square and minus 9y square, right? Now similarly, a polynomial involving three variables is called polynomial in three variables. For example, 25x square minus 49y square plus 36z. So over here we are using x, y, z. Three variables are used. Right. The three terms are 25x square minus 49y square and 36z. These are the three terms which are used over here to make this polynomial. Now comes polynomial function. So since polynomials are functions, these are represented by letter P. And suppose this polynomial is in one variable, say x square minus 6x plus 8, where x represents the variable over here used here. So over here we can say polynomial is a function of x. Similarly, if we denote the variable by a, so the function, the polynomial is a function of a, where we will say it is pa is equal to a square minus 4a plus 12. Similarly, if it is a variable t used, then the polynomial is a function of t, so it is represented by pt like this in bracket and t cube minus 7t plus 20. So only one variable, that is t, is being used over here to write it in a polynomial form, right? Now let us learn about standard form of a polynomial. When the terms of the polynomial are written in decreasing order of the power of variable, it is called a polynomial in standard form. Right? So what is polynomial in standard form? The terms of the polynomial should be written in decreasing order of the power of the variable. For example, as you can see in this polynomial, x raised to power 5, x raised to power cube, x square, x raised to power 1. This is a constant which also has a power, but it is 0. Right? So 5, 3, 2, 1, 0. Similarly 5, 4, 2, 0. So all these powers are in decreasing order. That's why we can say these polynomials are in standard form. Right? Let us take another example. Suppose we take this 4t raised to power 5 minus 6t plus 7t square plus 5t cube minus 6. Now this is not in standard form. Clearly it is not in standard form. Why? Because the powers are not in decreasing order. they are actually not in order, right? So to make it in order, that also in standard form, we have to write in decreasing form. So 4t raised to power 5, 5t cube plus 7t square minus t and minus 6, right? So over here 5, 3, 2, 1 and 0. As I told that even the constant has the power where x is raised to power 0 and anything raised to power 0 is 1. So we are not writing x raised to power 0, but it is there, right? Power is 0. So such type of polynomials which are written according to the decreasing order of the power of variable are known as standard form, right? Now let us learn about different types of polynomials based on number of terms. So based on number of terms which are present in the expression, the polynomials are further classified as monomial, a polynomial that consists of only one term, that is 3x, 4y, 7p square. It consists of only one term. Such polynomials are known as monomials. There is no addition or subtraction involved. Next comes binomial, a polynomial that consists of two terms, 3x plus y, 7y square plus y. Over here we involve two terms and they are combined together by mathematical operation of addition, right? So these are binomials. Then comes trinomial, a polynomial that consists of three terms, for example 3x square plus 8x plus 3 or 7y square plus y plus 8. All these are trinomials, examples of trinomials. Then comes quadrinomial, a polynomial that consists of four terms, right? 3x cube plus x square plus 8x plus 3. Over here four terms are there, right? Similarly in another example also four terms are there. This is polynomial in one variable, that is x. This is also in one variable, that is y. But together four terms are involved and they are combined using mathematical operation of addition, right? Now if we have more than four terms, so we can say a polynomial that consists of more than four terms is a polynomial, right? Like over here five terms are there, so it's a polynomial. So if it consists of one term, it's a monomial. If it consists of two terms, it's a binomial. Three terms, it's trinomial. Four terms, quadrinomial. And more than four, we can say it's a polynomial, right? Now comes degree of a polynomial. What is degree of a polynomial? The highest power of the variable in a polynomial of one variable is called the degree of the polynomial. What does it mean? It means that the polynomial of one variable, let us say x, whose power has to be highest. Yes, that forms the degree of the polynomial. Let us take an example. Suppose I say 5x square plus 3. Now over here x is raised to power 2. Even 3 has the power where x is raised to power 0. Now we have 2 and 0 as the power. The highest is 2. So the degree is 2. Let us take one more example. 4y cube plus 9y. Over here the power is 1. Y raised to power 1. Here power is 3. Highest is 3. 3 and 1, the highest is 3. So degree is 3. Yes. Let us take one more example. Over here we have 5, 3, 2, even over here 1, and over here x raised to power 0. So 5, 3, 2, 1, 0. So highest power is 5. So degree is 5. Yes. So let us take one more example. Over here 6, 3, 1, y raised to power 1. Over here x raised to power 0. Right. So 6, 3, 1, 0. Highest is 6. So degree is 6. So what does it mean? It means that we have to see the highest power of the variable in the polynomial of one variable, and that is known as the degree of the polynomial. These examples involve all polynomial in one variable. Here the variable used is x, here y, here again x, here again y. Right. Now to conclude, we can say that in general, what is a polynomial? A polynomial in one variable x, let us say of degree n, yes, that is the highest power, is an expression of the form. This is the expression as you can see over here. Yes, we start from the highest power to the lowest power. right? Why we start from? Because this is the standard form of writing, where a0, a1, a2, n minus 1 are the real numbers. They form the coefficients of the variables and they should not be equal to 0. And n is a non-negative integer. N represents the power, which should be non-negative. We say that it is a polynomial in x variable of degree n, because n, we are starting over here with the highest power, that is n, right? And polynomial is in x variable. Yes, so it is polynomial in one variable, that is x, degree is n. Over here this is the constant term, which also has a power, that is 0. Anything raised to power 0 is 1, so we need not write x raised to power 0, we just avoid writing it, right? So this is the general form or general expression of a polynomial, right? Now let us learn about different types of polynomials based on their degrees. So let us start with the first one, that is the linear polynomial. A polynomial of degree 1 is known as linear polynomial. For example, 3 plus 7 by 2x. Now over here, if you observe, x is raised to power 1. 3 has also the power raised to power 0. So highest is 1. Similarly, 7a plus 2. Over here, a raised to power 1 and 2 is x raised to power 0 over here. So the highest is 1. So when the degree is 1, we say it is a linear polynomial. Next comes quadratic polynomial. A polynomial of degree 2 is known as quadratic polynomial. For example, 5x square minus 3x plus 1. Now over here, x is raised to power 2. Over here, x is raised to power 1. Over here, x is raised to power 0. Highest is 2. So degree is 2. So it is called quadratic polynomial. Next comes cubic polynomial, which has degree 3. So over here, 4p cube, 2p square plus 5p, which is raised to power 1. 7 is also raised to power 0 over here. So over here it is of degree 3, as the highest power in this polynomial is 3. So it is known as cubic polynomial. And if the degree is 4, like in this case the highest power is 4, so we say it is quartic or bi-quadratic polynomial. So there are 4 types which we are going to learn over here: linear polynomial having degree 1, quadratic polynomial having degree 2, cubic polynomial having degree 3, and quartic or bi-quadratic polynomial having degree 4. So these are the various types of polynomials depending on the degrees, right? Now comes constant polynomials. What are constant polynomials? So we can say a polynomial that consists of only one non-zero constant term is known as constant polynomial, like 5, 7, minus 3. Only one term is there, that is a constant term, that is has to be non-zero, right? So every non-zero real number is a constant polynomial. It should not be 0, it should be a constant term, right? Now, what is the degree of a constant polynomial? When we talk about degree, we can say the power of the variable in a constant polynomial is 0. Therefore, the degree is 0. Like, for example, we take 3. 3 can be written as 3 into x raised to power 0, right? Because power over here is 0. Now, anything raised to power 0, we know it is 1 according to laws of exponents. So, 3 into 1 is equal to 3. We just avoid writing x raised to power 0. All these polynomials are constant polynomials. We just avoid writing x raised to power 0 over here. We simply write it is 5. It consists of only one term, that is a constant term. Such type of terms are known as constant polynomials, which consist of only one term, that is a constant term, right? Now comes polynomials. Zero polynomial, a polynomial consisting of one term, namely 0. Now over here only 0 is there, so it is known as zero polynomial. The constant polynomial 0 is called the zero polynomial, right? Constants other than which are not 0 are known as constant polynomial, and if the constant polynomial is a 0, then we specifically say that it is a zero polynomial. The degree of zero polynomial is not defined, right? Now, the general form of a polynomial is this. and suppose the coefficients, all the coefficients are equal to 0. All the coefficients over here like a, n minus 1, all these are turned into equal to 0. So what will happen? We will get a 0 polynomial. For example, you insert 0 in place of a over here. So all the coefficients are 0 over here. So final answer is 0. So it is a 0 polynomial, right? So with this we come to end of this video. Hope you have understood all the important concepts of polynomials. In the next video I will be taking up zeros of the polynomials. Okay children, thank you. Have a great day ahead.